Okay, in this video we're going to look at solving quadratic equations by factoring. And the next one we're going to look at solving by the quadratic formula. Okay, so first by factoring, okay, I have this here. So let me just expand this a bit here. Okay, so by factoring, if you have something like a times b equals 0, then the solutions to this equation are either a equals 0 or b equals 0 or both. Okay? So in order for this to be true, one of those two have to equal 0. So this makes life a bit convenient. So if we can arrange an equation so that it's 0 on one side and it's a product of two things on the other, then we can solve it nicely like this. If it was a times b equals 7, then there are many different options for a and b. But being multiplied to equal 0 means one of the two at least has to equal 0. Okay? So, I mean, this is convenient because we've just done factoring quadratics. So when you factor quadratics, you have them in the form of a product. Okay, so something like this. So if you had x minus 2 times x plus 3 equals 0, well, now you can say that x minus 2 equals 0 or x plus 3 equals 0. So if you're looking for all possibilities for x that make this true, well, then the first one is x minus 2 equals 0. Okay, the second one is x plus 3 equals 0. Now you can solve these two, very easy to solve, by bringing the 2 to the other side, or adding 2 to both sides, subtracting 3 from both sides. So by solving those two equations, you get x equal to 2 and x equal to negative 3 are solutions. Okay, so x equal to 2 and x equal to negative 3 are two values that make this true. There are no others. Okay, there are no other values that make that true. Okay, so they're the solutions to that equation. In general, if you have something like ax squared plus bx plus c equals 0, then you factor it to something like this. This is, one of the uglier forms. So mx minus s and nx minus t. Well, then you have mx minus s equals 0, nx minus t equals 0, and solving it you get x equal to s over m, x equal to t over n. Okay, and how you would do that is, say you had the first one, say mx minus s equals 0, so something like that. Well, you would add s to both sides, you get mx, so right here you can see it now, so mx minus s equals 0, so mx equals s, and then divide both sides by m and you get x equal to s over m, which is the solution I've got here. And the same process gets you x equal to t over n. Okay, so that's solving by factoring. So if you can factor it, then you can solve it. Okay, so here's some examples. Let's look at number 1. All right, so number 1, x squared plus 2x equals 0. Well, you can factor out a common factor for this one. Okay. So factoring out the common factor of x makes it x times x plus 2. And now we have x equals 0 or x plus 2 equals 0. Subtract 2 from both sides of that one, then you get x equals 0 or x equals negative 2. Okay. Another example. Same idea. The common factor for this one is 3x. So we factor out 3x, and we've got now 3x equals 0 or x minus 4 equals 0. Okay. So 3x equals 0, from that you just get x equals 0. And x minus 4 equals 0, you get x equals positive 4. So basically you've got something where if it's like this, x equal to the opposite sign of that is a solution. Okay. Something like this one, well, now we have to factor it. Okay, so this one has an a value of 1, so we can use just product sum. We don't have to use decomposition. Okay, so the product and sum are, product is 15, sum is -8, I get -3 and -5, so you can plug them right in here. Okay, and now you can say that x equals 3 and x equals 5. You don't really have to do this middle step here if you can see the answers right away. Another example here. Okay, so if we look at this one, first rule of factoring, look for a common factor. So the common factor of this is 2. Okay, so pull the 2 out, and then we still have a 2 in front of the x squared. So this does not have an a value of 1, so we need to use decomposition. Product sum and decomposition. So here's the product. The product is 2 times -6, which is -12, and the sum is 1. So we get -3 and 4. So -3 times 4 is -12. -3 plus 4 is 1. Okay. So we can use decomposition now. So we decompose that middle term with these numbers. And then we take the common factor of the first two, which is 2x. Common factor of this one, which is -3. X plus 2 is left over. So we can write out that common factor, which is x plus 2. And then you got left 2x minus 3. And the solutions are going to be x plus 2 equals 0, or 2x minus 3 equals 0. So from this one, x equals -2. From this one, you bring the 3 over, so 2x equals 3. Okay, so 2x equals 3, and divide by 2, and x equals 3/2. Okay, so that's how you'd get these two answers. Another one, let's take a look at a difference of squares. Okay, so here's a difference of squares. C squared minus 36 equals 0. So c squared minus 6 squared equals 0. And c minus 6, c plus 6 equals 0. So you've got, in that one, c equals plus or minus 6. Okay. Another difference of squares, not as nice. So 4k squared minus 49 equals 0. 2k squared minus 7 squared, so that's a difference of squares. 2k minus 7, 2k plus 7. And from this, we get 2k minus 7 equals 0, 2k plus 7 equals 0. Rearrange, solve it, and you get k equal to 7 over 2, or -7 over 2, or plus or minus 7 over 2. And the next one here that we're going to look at is hopefully something you recognize. It's a perfect square. So if you take half of 18, that's 9, square it, you get 81. So that's the sign that you have a perfect square. Half this number squared is that. Okay, so you can write it like that, so you can see that the 9 appears twice there. So it is a perfect square. A minus 9 squared equals 0. And this kind of quadratic, you only get one solution. There's only one value of a that satisfies that equation, and that's a equal to 9. Okay, another perfect square, not as nice a one, but can you write this as a perfect square? Hopefully you can. So 16y squared is actually 4y all squared. So you can write it so that 4y is the variable. Okay, and then what's left over here is a 6, but half of 6 is 3, and that's 3 squared, so you have a perfect square. Okay, so 4y plus 3 all squared equals 0. 4y plus 3 equals 0, and y equals -3/4. So in perfect squares, you only get one solution to the quadratic equation. Okay, and that's it for examples on that.